All right, today we're starting our next unit on kind of a combination of some different things that are in our 8th grade standards that we need to cover with you guys. So today we're going to be learning about the Pythagorean theorem. So in your table of contents, the title of today's lesson is Pythagorean Theorem. Then on the next clean sheet of notebook paper in your spiral notebook, write the title, Pythagorean Theorem, at the top of the page, and then the essential question for today: how can I use the Pythagorean Theorem to solve for missing side lengths on a right triangle? Hit pause and set up your table of contents in your notes. When you're ready to move on, hit play. All right, first, you need to copy down all of this, including this formula here. This is the Pythagorean Theorem. Copy this whole slide down into your notes. What you are copying, what is the Pythagorean Theorem? It is a rule that helps us find, that should say, helps find the distance or measure of one side of a right triangle when the other two measures are known. So we're going to have a right triangle. Remember what that means? It means it has a right angle in it. Two of the sides we're going to know. The third side we're not going to know. Okay? And then we're going to plug in the two sides that we know into the Pythagorean theorem, and then we'll use algebra to solve the equation. And then copy this down: a squared plus b squared equals c squared. This is the formula that we call the Pythagorean theorem. Make sure you have that written down. If you're not done copying, hit pause, finish copying. When you're ready to move on, hit play. Okay, underneath the formula that you just copied, a squared plus b squared equals c squared, we're going to do an example. And I want you to draw a little right triangle and label 3 and 4, because we're going to label some things on here so that you know what is A, what is B, and what is C. Okay, so draw a little right triangle, and let's work this out. In the Pythagorean theorem, we have 3 letters, A, B, and C. A and B are going to be the sides that we call the legs. Okay, they are the two sides that form the right angle, and they're going to be the shorter sides. So A and B, or I could have done it the other way around. It really doesn't matter what you say is A and what you say is B, as long as they're the two sides that come together to form the right angle. And then C is going to be the hypotenuse. I want you to label on your formula that C is the hypotenuse, which is that longest side, and it's the side that is opposite, so like across from the right angle. That's what the hypotenuse is. A and B are the legs that form the right angle. So on any right triangle, when we're using the Pythagorean theorem, that's how we're going to figure out which is A, which is B, which is C. A and B are the legs that form the right angle. C is the hypotenuse, which is that longest side. So now I'm ready to work out this problem. I know A and I know B. I don't know C. So I'm going to write my formula: a squared plus b squared equals c squared. I want you to do this with me. Call this example 1. Okay? And so we're going to plug in 3 for A, so 3 squared. We're going to plug in 4 for B, so 4 squared. And then we don't know what C is, so that's c squared. Next, I need to work out my exponents. 3 squared, that means 3 times 3, which is 9. 4 squared, that means 4 times 4, which is 16. And I still don't know what c squared is. Next, I add together 9 plus 16, and that is 25. And then I want you to remember, we talked about squares and cubes, square roots and cube roots at the beginning of the year, but it's been a while. What is the inverse operation of squaring a number? So far, when we solve equations, we use inverse operations like multiplying and dividing are inverse operations, adding and subtracting are inverse operations. So the inverse operation of squaring a number is going to be the square root. So I'm going to say square root, square root. And what that means, square root, is I'm trying to figure out which whole number times itself is going to give me that number under the square root symbol. So what times itself gives me 25? 5. When I do the square root here with the c squared, the little exponent of 2 and the square root symbol cancel each other out. We just have c, and we're done. So c equals 5. So that's how we use the Pythagorean theorem to find a missing side length. Now let's try another one.
That's what I just went through. These are our process, the steps of our process. You don't have to write them down, but rewrite the formula, plug in the numbers we know, use algebra to solve. You can check your answer by plugging it in to make sure that it works. All right, here, let's try another one. Call this one example 2. All right, so I'm going to label what I know on my triangle. Now remember, A and B are the two sides that form the right angle. So A is 12, but I don't know what B is. And then C, the hypotenuse, is 15. So let's plug that into the Pythagorean theorem. Okay, A is 12. Don't know what B is. And instead of writing C, I want to put 15 squared. All right, now we need to work out our exponent. 12 squared, that's 12 times 12 is 144. Don't know what B squared is. 15 times 15, that's 225. Okay, next I'm going to subtract 144 on both sides, just like I'm solving an equation. 144. Okay, those cancel. B squared equals, and then 225 minus 144. 81. All right, at this point, what number times itself gives me 81? I'm going to do the square root. B equals 9. So B is 9. So my triangle is 9, 12, and 15. And so this Pythagorean theorem helps you find the missing side length for any right triangle. Okay, now what if I have to take the square root of a non-perfect square? There at that last step, so far I got 81 and had to do the square root of 81 on this problem. I had to do the square root of 25 on that problem. Those both had whole numbers that were the square root, but that doesn't always work out. Let's review. We learned this process at the beginning of the year, but how do I find the square root of an imperfect square? The first thing we do is think, what is that which two perfect squares is that number between? So if I was doing the square root of 20, then I would first think it is between which two perfect squares it's between, and we draw a number line, the square root of 16 and the square root of 25. The square root of 16 is 4, and the square root of 25 is 5. Since I know that it is going to be somewhere between 4 and 5, this is the square root of 20, I know that I can go ahead and say it's going to be approximately 4 point something. Okay? Now, how do I know what the decimal part is going to be? I subtract two things. The first thing I subtract is my imperfect square, square root of 20, minus the square root on the left. So 20 minus 16 is 4. Then for the denominator, I subtract the two perfect squares on each end. So 25 minus 16, that is 9. The last thing I do is divide 4 divided by 9 to get the decimal. And it's going to tell you to round either to the tenths or to the hundredths. We'll just say it says to the tenths for this one. So it's repeating. It's going to be a repeating decimal. So we would round that to be approximately 4.4. So this is not new. We learned this at the beginning of the year. It's just been a while since we've done that. And we're now applying it to the Pythagorean theorem. Okay, which of these triangles does the Pythagorean theorem apply to? What kind of triangles can I use it on? Only right triangles. So 1, yes. 2, no, because that's not a right triangle. It doesn't have a right angle. 3, yes. 4, no. 5, yes. Okay, so let's try this first one here on the left. If you feel like you're ready to try an example on your own, go ahead and do this one. We're going to call this example 3. All right, and I'm going to say A, B, and then there you have C. So 6 squared plus 8 squared equals C squared. 36 plus, what is that, 64 equals C squared. We add those together and get 100. Last step, square root. They were nice and gave us a perfect square. 10 equals C. Let's try this one. Call this example 4. So remember, A and B are the sides that form the right angle. C is the longest
plug in 5 squared plus y squared equals 8 squared. That would be 25 plus y squared equals 64. Subtract 25 on both sides. Y squared equals, okay, 14, that's 9. 39. Aha! We have one that is an imperfect square. This is what I was hoping for. So now, when I do the square root of 39, is that a perfect square that I can just say the whole number? No. I'm going to have to do my little process. First, which two perfect squares does 39 fall between? It falls between the square root of 36, which is 6, and 7, which is the square root of 49. So the square root of 39 is between those two. Since it's between 6 and 7, I can go ahead and say it's approximately 6 point something. Alright, to find the decimal, I'm first going to subtract 39 minus 36 is 3. 49 minus 36 is 13. And then I have to just divide that. Where do I have room? I'll just go in the triangle. Why not? 3 divided by 13. 13 goes into 30 twice. We're going to round to the nearest tenth. And then that would go 3 times, so 0.23. That's going to be about 6.2. Okay? So using the Pythagorean theorem, finding the square root, you're either going to have it a square root of a perfect square, or it might be the square root of an imperfect square, and we use that process that we learned earlier in the year. Last example, and then you can get started on this. How high off the ground is the owl? So they're asking us to find this right here. This is where our right angle would be. Call this example 5. All right, A, B, C. So I'm going to say 12 squared plus B squared equals 43 squared. 12 times 12, 144. I don't know what B is, so I just leave B squared. And then 43 times 43 is 1,849. I subtract 144, subtract 144, cancel. B squared equals, when we subtract, we get 1,705. Now, you may not immediately know your perfect squares this big. So if you pull up Google and type in a list of perfect squares, you can find the perfect squares that are really, really big. So I only had you go through like 20, I think, in your notebook. For this one, it is going to fall between 41 and 42. You may not have known that off the top of your head. To be honest, I didn't know that off the top of my head. I had to look at my little list that I have. So 41 is the square root of 1,681. 42 is the square root of 1,764. And 1,705 is going to be between those. All right, our process to get the decimal, I'm going to say, first of all, I know it's going to be 41 point something because it's between 41 and 42. Then I subtract 1,705 minus 1,681. Let's see, that would be 19 plus 5 is 24. And then I subtract 1,674 minus 1,681. That's 83. So when I divide 24 divided by 83, I'm going to have to put a decimal and a 0. That's going to go in what? 3, no, 2. 83 times 2, 166. 240 minus 166, thank you, is 74. And so whatever I get there, it's still going to be less than 5. So I'm going to say, no, I have to keep going, okay, 740, it's going to be 8. Alright, so it's going to be 41.3. At this point, you should be ready to start on the digits assignment. You're going to have to go into 8th grade digits. We haven't worked out of this year yet, I don't think. Maybe we have. 8th grade digits, not 7th